Hello everyone, welcome back to Chemical Engineering Education channel. I am going to show you how to build a complete Reynolds number calculation in Python that you can actually use in your engineering calculation. This covers everything from the basic theory to real world application in chemical plants. Let's start with the fundamentals. The Reynolds number is calculated using the formula RE equals rho times V times D all divided by mu. Breaking this down, rho is fluid density in kilogram per cubic meter, V is the flow velocity in meter per second, D is the pipe diameter in meters, and mu is the dynamic viscosity in pascal second. This single dimensionless number tells us everything we need to know about flow behavior in pipes and process equipment. Now, why do we care about Reynolds number? Because it predicts flow regime. Below 2300, you have laminar flow, predictable pressure drop but lower heat and mass transfer rate. Above 4000 we get turbulent flow, enhanced mixing and higher heat transfer but also higher pressure drop. Between 2300 and 4000 is transition flow. It unstable and unpredictable, so we avoid this in process design. Let's code this up. First, our main calculation function, I am calling it Reynolds number, and it takes 4 parameters: density, velocity, diameter and viscosity. Notice the detail doc string. This is crucial in engineering code, like calculate Reynolds number for fluid flow. So here I specify units for every parameter because units error cause expensive mistake in the real world. The calculation itself is straightforward, just our formula implemented in Python. The function returns the Reynolds number as a dimensionless value. So here is the key point: dimensionless number, proper unit documentation and simple calculation. Next, we need to classify the flow type. The classify flow function takes our Reynolds number and apply the standard engineering criteria. If it is less than 2300, return laminar flow. If it is greater than 4000, that will return turbulent flow. Everything in between is transition flow. These values are industrial standard for pipe flow in chemical engineering calculation or chemical engineering application. Now I will create an analyze flow function, put it all together. The function calls our Reynolds number calculation and classify the flow and gives us formatted output. This is the function you would actually use in practice. It calculates the Reynolds number, determines the flow type and presents the result clearly. Notice how it returns both value, so you can use them further calculation. Let's test with real engineering scenarios. For example, water flowing through a 10 cm diameter pipe at 2.5 meter per second velocity. Using water properties, density is 1000 kg per cubic meter, viscosity 0.001 pascal second at 20 degrees centigrade. Running our analysis function gives us a Reynolds number 25000. Flow type will be turbulent. So now here I can show you the code. So here first that function is Reynolds number, and then here RE, here input is density, velocity, diameter and viscosity, and RE is equal to density, velocity and diameter by viscosity, and that will return the RE value. Then another function is classify flow. So here that whatever Reynolds number is calculating in that function, so that will be input of the classify flow and it will give that corresponding flow type. And then here is the main function that analyze flow. So here we have to give the density, velocity, diameter and viscosity, and then in this function, inside this function, that Reynolds number function is calling, as well as classify flow function will that called, and based on that it will give the proper result. So print flow analysis result, then Reynolds number, then flow type. Now here I am taking one real life example, that water flow in a pipe. If I run that, so here if I run that, so we'll get that example 1, water flow in pipe, flow analysis result, Reynolds number is 25, that 40.00 and flow type is turbulent. That's how you build a professional Reynolds number calculator in Python. The code is here. First Reynolds number function, then classify flow function, then analyze flow function, and then here are the example calculation. If this helped with your fluid mechanics calculation, hit the like button and subscribe for more chemical engineering programming tutorial. Thanks for watching.